welcome.
Hi, how are you?
Is the panel here?
Yeah,
Yep.
Okay.
we just started live casting.
Are you part of the camp?
Yeah.
Okay. You get a front seat.
So maybe that's the one.
Hi, I'm Pete out there.
Yeah. So I think we'll.
Oh, we have many people now.
So you think like we can sit like this?
I think that would,
Okay.
I think that would be more efficient. And we were waiting on cameras, right?
We'll use modern technologies here.
So is that the application you wrote? Really? Yeah. Is it tracking automatically?
Something really, really impressive.
So yeah, we have to update us with the cameraman. Ready?
But that one starts talking. That's a separate debate. Yes. My first little introduction to robotics, always stuff that comes. Do you? So it's a good question to start off with. It motivates, it brings up the emotional aspect, societal aspect. Yes. That's sometimes it's definitely something. I usually try to put things in these. Not instant. Maybe the end of the week. Maybe the end of the week, but not tomorrow. There's the cameraman. Oh, yeah. That weather's nice.
Already? That corner.
Okay. Okay.
So we have to make sure that this is live streaming and we don't log on.
You might want to focus.
I just lower that because it go around and move up.
Oh,
And there are a few variants on that.
So, I think we can start to be respectful for the time. Okay. Thanks everyone for joining our panel. Not many of us just showed up, but at least all panelists are here. So let me introduce myself, and then I think every panelist will just speak a few words about them. So my name is George Fomichev. I'm a CEO and founder of Endurance Robots. It's a very early stage startup. We make robots for education. So the reason that we wanted to organize and make this panel, just to talk a little bit about opportunities that open source robotics bring to people. So we feel that it's a great market opportunity right now to get educators involved into really practical robotic things. And we're going to speak a little bit about this in this panel. So I'd like to meet Peter.
yep. I'm Peter Zeno. I'm a PhD candidate here, and my thesis is actually in robotics. And it's sort of putting neuroscience and robotics together. That's what I'm trying to do.
Hi, I'm Misha Salman. I'm faculty in the Mechanical Engineering Department at Stevens Institute of Technology in New Jersey. I primarily teach courses relating to robotics, product development, mechatronics, and control systems. And I also run a few outreach programs for younger youth robotics.
Hi, I'm Dr. Azhar. I'm from BNCC, City University of New York. I'm a assistant professor, and I have been in robotics for almost a decade. My research is in behavioral interaction. I also been involved in competition robotics for almost 12 years now. I'm part of this competition called Robo Junior for high school students, and I'm the organizer over there. Yeah, I have been working towards creating a region for high school students and undergraduate students using robotics.
I'm Tom from Rutgers University. I'm part of the design of the engineering system for the industrial system engineer. And every year we have like the 15 projects ongoing, and many of them are robotic systems. So the robotic system we develop, including Amdal crafter and robot for robot for like pipeline inspection things, and basically we were trying to get the students involved with robotic development.
So the first topic that we want to cover, so how do you guys think open source community for robotics should be created? Do you have some ideas? Do you have some vision of how open source community should be developed in terms of getting educators involved into this process? So we have already like resources like GitHub and Structural Hackaday where you can share projects. But is it good enough for educators to get involved? Would you guys want something to be more advanced in terms of getting people all together? Like not only authors and makers and students, but also professional professors and
Well, that's a good question. So you're looking at kind of a diverse crowd, so different levels of experience and what those projects would be. So you need to probably categorize that somehow, and also make it rather simplistic to be able to get those things like on the web. Have some sort of bottleneck. good way.
So I am actually a big proponent of websites and services like Instructables and GitHub. I know that many of my students and student projects have either started based off of things that they researched on such websites and also have added back towards those services. Now, the question being, should there be essentially a higher level, and how could we achieve a higher level in the academic world? I think it's an interesting idea. I don't have particular thoughts on how to do that effectively, but perhaps it could be some kind of unification of those things with maybe like a super user type of interface. So we don't need to start from ground zero, but we can actually build off of it and have like the user mode or something like that, the more advanced stuff.
Well, I have been involved with the high school teachers and also undergraduate professors and putting robotics in the classroom. And it's a challenging thing because robots are a lot of work for the students, for fun, but for teachers or professors, you have to create materials and make sure that it works. So technology-wise, but I think creating materials for professors or high school students, right, with open source materials in mind, so you can do a package to them, right, and maybe starting some pilot and then having some events around it. I think that will get them involved. So, so this way you have a model that can be expanded to other places. Let's say you come to my class and you give the package to me. Okay, here's the package you can use for teaching these materials. You can use robotics, and I use that, and then I can tell you how it works and stuff like that. Do the self-assessment, write papers and stuff like that. I think that will, get people more involved because you can see that it's working in progress, and we are using it in the classroom. Okay, and especially for high school teachers, they really don't have time for creating new materials most of the time. So, like I'm right now working with 2 high schools, and I basically handed them the robots and the materials, and they said gonna run it for a year, and then I like to be independent from this whole process, and then next year gonna take over and continue from there.
So do you feel like lack of curriculums for your classes, for you ran out of a lot of materials that you can get from research? Do you think that you need some sort of like starting point where you know that you're going to teach like about microcontrollers and DC conversion, or is everything is okay that is provided or in a website or your product?
Well, I think the challenge here is that when we teach in a classroom, it has to be customized, right? So we all have different needs, right? So when you go to a website, you see something in you, right? So we need to have a way to kind of work with their teacher or professor to make sure that their needs are met, right? And then we have some setups. And as we build this open source environment and also open source curriculum maybe, right? So people can go and say, okay, you want to teach this topic, here are some materials over here you can use, and the whole setup is here. And these are the professors used before, or these are the teachers used before, and then what? But that kind of setup would be nice, I think. That's what I felt like, even for Lego robotics, and this has been around for almost over a decade, right? And so much material there. But if you go online and then try to find something, you're gonna be like, okay, this doesn't work for me, this doesn't work for me, right? So you have to be. So we worked on this for a long time and creating materials for specific classrooms and topics and stuff like that. And a lot of the stuff probably can, take over and then put it in for the, let's say, open source robotics because they're overlapping topic-wise, right? So you say using Lego robot, you can use open source robot to teach the same topic. And how do you do that happen? Right? So it's going to be translating from those robot to this robot and then make it work.
Robotics is such like a interdisciplinary like a field, and I would say first of all, when we talk about robotics, and what type of robotics we have to use for open source, because I saw here has a HVA, and then we have like joint robotics and the robotic arm, and then we have unmanned aircrafter, and which one you really want to use lesson to work on. Right now I have all kinds of robots some of them, using the robotics arm to do the picking. And then for that project, the knowledge you need to have, first of all, is kinematics, planning, motion planning. And then in order to grab the things, then you have to have a very, very clear understanding of how the arm to work, and then vision system, and then the many stuff you need to integrate. And then for AVA is totally different, right? SLAM, and then and also the hardware design, because this is 4-wheel one, and what was 3-wheel one, and then also has a lot of component there. So it's very broad area. When we talk about open source, and we may have to provide a boundary. It's after, and also for hardware, and some we want the student to use in the get the hardware from outside, or make to make by its component by themselves, and then if they have to make them by themselves, the machining, SolidWorks, and all those things has to be there. So it's I'm teaching the design of engineering systems. So the first semester we cover all those topics, but I have to say, most students are not ready, but then getting exposure. And then the second semester, we have to push them. And how to push them? There are many ways. And one is, if you cannot get done, and then you get F, then everyone work very hard. But if you tell them, okay, yeah, it's just a hobby, and then you are going to see very like a shabby stuff. So really, it's the goal, and then it's a goal. Will determines what kind of course you want to offer. I give I asked like a mechanical engineering student to develop robotics. I asked a computer science student working with me to develop robotics, and I have like an industrial engineering student working with me on. So they all have a different like a background and have different needs, and it's going to be very, very challenging. So when we talk about the open source, we really have to make some like a constraint or boundary on that. So are we talking about like HV or US or robotics, going to robotics?
The thing is that you can do like open source, but then divide them into different categories. Where you have like ground robots, you have let's say UAV, you have probably some spider-like robots. So you make different categories, and it's only for mechanical part. Then you go deeper inside about software, where you have like robots, where you have solutions for like Arduino, and you can actually find whatever you need. So what do you guys think about peer-to-peer review? Is it something that people would really need to have? Because, for instance, you make your project, or your group of students make a project. So how you present it to public? Of course, you can publish it, you make it visible on your website, but if people do not visit the website, they do not do special search, how they might find it. So if they not subscribe to your mailing list, so they don't get these updates. So do you think like I mean, of course you can, like I said, upload it on Instructables, but then it's also not like very easy. People make comments, they can click the button that they made it. But what about peer review, when you get some academics involved and reviewing it? Yeah, it's a nice idea that you made it. Like Peter is working on autopilot, autonomous vehicle, but he's not using LiDAR right now, right? Like, so he's using a little bit different technologies, and probably Peter make it on this resource public, so then some can come up with the idea, hey, you can use this LiDAR, they're very cheap, they're affordable, and here's the software that you can use on your robot. Then this whole society will get additional knowledge. What do you guys think?
So almost like a forum.
Well, yeah, probably like forum, but still you need a review. step because you make something in advance. So right now, what I found out that a lot of people is start from the scratch all the time from the very beginning. They
Yeah.
take Arduino, they take
Yeah,
board, they do soldering, but what if it's already there and they know that it's well written, this is like a new product.
But yeah, the only thing is, yeah, people go and do it by scratch, but that's a good way of learning.
Yeah, sure.
And sometimes you don't want to just hand out the product because I mean, unless it's an essential part of they want to go on to designing something else that's not out there or whatever. And yeah, this module portion would be great to just add on. Like so. My project is just like a lot of research. So you're skimming the web for what will work. You try out the code, and I think I don't know.
Yeah, but it takes a lot of
some
time.
that feedback.
For instance, we tried with OpenCV, we couldn't do that file on our product, we use Google.
Right.
So what if you put a problem and then people can help you with it? It doesn't mean that you don't get knowledge, but
Right.
you don't waste time on checking something that is not working, not perfect for your particular need, because it takes time to find it.
Yeah, the only thing I would say is that when they get in, when an engineer gets out into the field, what they have to do is they can't find a project that's exactly the same as theirs. They have to do the research, and they have to research what works best. Research sonic sensors versus IR sensors, distance sensors, and all that, and what code works, what code doesn't work. Get feedback. So I mean that in that part, it is very difficult, but that's what the reality is when you're out there as an engineer. I mean, it would be great if you could have more complex things like the robot operating system, more visual pattern recognition, and that sort of stuff that you can more easily. Because I've seen stuff for Raspberry Pi that you go through this, try that, and then ends up not working or whatever.
So it sounds like what you're describing seems to become a fusion of a wiki page with something like a GitHub or instructable format for delivering material, but also including some kind of open access journal, such that you have some form of peer review, but in an open access format, you would allow people to log in and just check without necessarily registering or anything like that, so that the general public can get access to it. Now, kind of backing up a second, I think that the whole question in general about is there a need for such a thing, for such an open access format for, say, educators, and how do you approach it? It's kind of its own optimization problem, because you can look at it at the very broad, big picture, higher level. Well, here are the steps you take when you want to solve any form of engineering problem. You need to look at what the problem is, what are the needs to solve that problem, what is available to allow you to solve that problem, and what options do you have, what concepts can you develop, be they physical or just hypothetical, such that you can address those issues and then move forward with analysis and so on and so forth. I think that maybe it could be set up in a hierarchical manner, such that you have this very, very general approach for someone like a high school teacher who may not have any form of engineering background but wants to bring this to their classroom somehow. So that it's basic, well, here's a problem. What are the real points in the problem? How do we break it down, address that in stages? But then you can go a little bit deeper and say, well, okay, we know that we can solve this problem using a ground-based vehicle, for example. Here are some of the concepts that we need to consider. Well, we can start at the very, very basic level where we need to move and we need to detect. And somehow we need to bring those things together. So there's the basic idea of, can I use sonar? Can I use some kind of vision-based process? Can I use infrared? But then you can go deeper and then implement SLAM so that you can do better localization and refine your performance. I'm not sure how that can be efficiently implemented in a format with a high level of peer review. It sounds like it may be possible.
So the way I look at robots in education is that if you using robots to teach the materials, like I see your point saying that I want to teach this topic, you want to start from scratch, like go to SLAM right away. And the robots already does work on SLAM only, right? So for that, I don't want to worry about how to make a robot, right? I want to have a robot already where I can apply, the SLAM algorithm or things of the nature, pattern and finding it like that, right? So when I go to high school, let's say a teacher wants to work with robotics, I want to ask them what your expert is, how much you know. If they don't know anything, I said, I'm going to start with the robot. Because I'm not interested to give you the whole thing from scratch, because I'm interested to show you how to do problem solving, right? So this is good for you right now, and then let's move on to the next thing. So if you think of a spectrum from education level, from the high school to, let's say, graduate level, right, you need to have this scaffolding of different materials, right? So if you go to high school, we are more interested in the student to be interested in this topic and get them exposed to problem solving, how to get this idea going, right? And then come down the graduate student, they kind of started going to technological part, more like a technical part. By the time they go to the four-year college, and when they're finishing the four-year college, doing projects like AI classes, stuff like that, right? And then you go to the graduate school like you're doing a different kind of thing. I think so you have to have all the spectrum here, right? So you need to have materials for these different audiences, like I said, right? So for undergraduate student, graduate student, high school student. Now within the students, you also have advanced student versus beginner student. So you have a lot of materials. I think we probably start somewhere. Like, so if you want to create materials, let's create the materials for professor here or me or someone else here. Then let's create the materials for them. And then I think if you the way open source work, right? It becomes like a community work. So people drive the need for what people need, right? So we can see that community and then growing. But I think having a structured thing which is being reviewed by a couple of people saying that this work and I can vouch for it, that's a good thing because we can say, okay, this is a good thing I can grab and I can just use it from there. I think that's very valuable in the long run, right? But the problem with I think open source robotics is the challenge I say is that you need to think about the hardware, also think about the software, right? And you have to think about which audience is looking at it. If it's, the audience is going for the software, I mean, that's the computer science student, and they're working with the software only. They don't worry about the hardware stuff, so we have to give them something that they can start working with software. On the other hand, if you look at a student, a beginning student, they need to work on the hardware because they need to understand how that works. You need to give them something where software is ready, but they can work on the hardware and apply their knowledge and see where they're going. So I think coming back to the point, I think we need to have this whole spectrum of material, as I said, and you can have this places where people can go and say, okay, grab the material. So that would be great. And I think it's very challenging to make it happen because right in the get-go. And also we need 3D printer, right?
Yeah.
So that's
well, not for all, but for some robots.
for some robots you need 3D printer if you want to go the hardware side, right? So that kind of stuff. And I know that I'm involved with a professor from Australia, and he works with NIST, so they have been talking about these particular challenges that has been dealt by PhD students and like PhDs and people like in the field. And these are like real life problems. So what they're talking about is how about we take this problem, right, and give it to high school students, and let's see how they solve this problem. Now the idea here is that you want to get some ideas out of the box. Because when you PhDs and doctorate and you have all this knowledge, you're very focused on solving the problems right away. So when you give the problem to anybody like high school and then give them a problem, and they're kind of sometimes you'd be surprised that the out of the box thinking coming over here. And again, the same idea again, you would have an open source robotics and they have all materials you can download and have a robot that you can build, right? Which could be used for the real world. Because the whole idea is here is that we want to give the student a real world experience, right? So we can give robots that are used in the real world, they'll be more excited. Yeah. The whole field for this, like the whole robotics field you created. And I remember watching this whole 6 feet drop. So robot has to survive this drop. So you go to this scrapbook and then the robot just drops, and you see the robot drop in like 3 feet. So if you see that, you have to make the robot strong enough so you kind of get up and then start going again after this drop. So it's a real life problem you can create, and so you can be really excited about it.
So I like the idea when you said that for like software engineers and hardware, you definitely need some other materials, but that it will also bring them into this field, because then, for example, software guys they already see working mechanical part, and they will not be scared to do any soldering or anything. So they can just get this project, for example, even order it from a person who maybe is new piece of work, and start working on this project. So I spoke with a lot of software guys when they started to do their own business. When they understand that it's not only the software, they cannot do it all remotely, because they have to have real units in front of them and make sure that it works, let's say, smooth enough, the server connects is stable. They have to deal with mechanical things. So they need to get this unit in hand and make sure that it works perfectly. So one of my engineers, he never took our selfie bots when they are perfectly ready. So he said, get it, test it, make sure that mechanical is everything working, hardware is working, then I'll do my job. So in this case, I think that making this in a community where you have, like, for example, perfect hardware thing that could be taken by software engineers, and you already have this review that this mechanical thing is working and is well documented, and some other schools are already doing this research based on this tool. We'll probably get some positive feedback.
Yeah, first of all is I guess first of all is we really have to have some language. There's some people with so diverse background. So I believe there is a group of people who are trying to develop the concept called use the robot on college something. So to work on that. So then people can use the same language to talk to each other. Otherwise, there's so many like different type of robot, and it's going to be very tough. So I know last week or 2 weeks ago, submitted like going to protocol on this type of thing. Then I think I would say the idea is good. At least to give people with a different background the same pay. Otherwise, the software guy and look at the hardware and then come up with some language, weird language, and then the hardware guy brings some like a very different type of language to the software people, and then they're not going to communicate well, and then it makes things very difficult. Because if there's some common language, then at least it's going to be easy for them to communicate with each other, and they don't have to start with the many unpredictable like error. And another thing is that I'm working with students with different background. The computer science people, they can do mechanical stuff if they're really into that. So I have 2 computer science students right now. It's design the common aircraft stuff, and then the hardware. Because we are going to attach different type of things and then do different applications for them to build by themselves. So the key is really, first of all, they have to have an interest, and so different level people will really have to deal with different solutions. Good student, average student, and then just a beginner. Then you have to have a different solution for them, and then the first thing we need really is a common language. Yeah, that's it. That's my suggestion.
Yeah, so it sounds like maybe one form of the solution may be that you have the hardware and software developed such that you can make available the entire functional system. But depending on what your interest is, if you want to develop the AI engine, or if you want to further develop a different hardware platform, if you you know all of the module function, you could treat each module as a black box. I know these are the ins, these are the outs, this is the performance, how it does it, let's not worry about it. And depending on what it is that you want to achieve, you can remove one of those modules and say, I will redesign this module. But again, it becomes a daunting task to make it applicable at all of those different levels for the introductory student and the nominal student and the advanced student, graduate student. So we should start somewhere.
I think the challenge here is that what's your objective, right? Teaching objective. That's the first thing, right? So if you're a research, we're doing research with a student, that's an awesome thing to be. I think it's a collaborative environment. You have a computer science working with a student, right? And this is great, and they can learn from each other, and it's a fantastic environment. And research is something open-ended. One semester, two semester, you know, years, right? Years and years. But then you go to the classroom setup, right? I have 12 weeks, right? Then within the 12 weeks, I cover robotics maybe for 3 weeks. So now, how do I make things happen in 3 weeks, right? So you see, you have to figure out what's the constraint you have, and then kind of start this audience. I think that. So that kind of setup. You can have robotics as part of what you have the whole semester, and then you can basically create lectures for them. And then your high school, you have a different audience, different objective, right? So I think starting to have materials will be really useful for both for curriculum, for hardware and software, and then have a model like this work in this classroom, this work in this research project, this work on this. Things to bring to the point, having this peer review thing, like okay, I downloaded something, okay, from his website and created something, and then I can say, oh, it worked, thank you, and I'm adding something to this. So my student created this, uploaded that. So something like if you think about in Khan Academy, I think is doing that, or like Scratch, you know, those open source environment where you can have a game someone made and you can spin it, right? So you just click on it and then spin out that thing and then create something new. So there's nothing wrong with someone this company giving them the credit and then you adding something to it and learning from the whole experience. I think having that kind of stuff is very possible in this open source, you know, environment because we can do a spin-off of your project or his project or my project, right? And then you can create, and that kind of opens up so many things you can do. And having this community where you can have this website where you can have spin-off different things, that can make that kind of setup really useful. And then having a place where you can buy the materials is very important. I think I cannot stress this any further because when I look at a project, I say, oh, this looks awesome. What do I need? Right? And I look at this thing, I might need this, I might need this, look at the picture, I can figure this out. So you have like a professional setup. You buy this thing, here's the package, click on it. This is gonna cost me $10 or $20. Arduino does a good job with that kind of stuff sometimes, you know, when they have the project like that, you can go and buy stuff like that. I think that's great. AWS website, I think, is so right. So they are good at that. But I think that's important that when my student wants to work the project, I said, find a project that has all the materials so you can know what to get because you don't get stuck in the middle. I don't know what to do here, right? So I think that's another challenge. I think.
I could add just one small thing to that. So not in an open source forum per se, but MathWorks, who generates MATLAB, Simulink, I'm a big proponent of their software using a lot of courses. They have a structure for this already. And I've actually used their materials where people could submit for funding to develop a course based on their software. And they have entire curriculum that are available where I've downloaded robotics courses where we use X platform available commercially off the shelf. And we went through these types of exercises for projects. And in similar manner to what's being described, people will work with that as a starting point. And then, well, I took this and I wanted to focus more on the slant element. I wanted to focus more on the higher level, how do we address the problem element. And people show how they've expanded upon it. And they can give feedback. But because it's already been funded through a granting agency, so to speak, it is to a level peer review because they don't want to put their name on something that isn't. So there is a mechanism that does exist, but it's not open source. So maybe taking that as a start would also help.
Looks like it's more about like the software. When we talk about this toolbox, it's more software oriented. So basically, you want to get the hardware ready. So that's basically right.
Generally, I mean, I'm a mechanical engineer through and through, but in most of my robotics and mechatronics related courses, it is the software that's being developed. Now that could be partially biased because coming from a mechanical background, we come in with the expectation that you already know how to deal with mechanical systems, and this is where you need to grow. But there is a need for people who don't have the mechanical experience or aptitude, but they understand the programming, they understand the logic, and they want to be able to apply it to something.
So, yeah, I'm happy that we jumped to software thing. So, we are also considering that in some cases, hardware and mechanical engineers require more than software solutions to install and to use the robotics. So what we have now is a robots where you can do all kinds of measurements and data collection, data analytics. But what about some sort of artificial intelligence? So what if we can set up something like chatbot, real chatbot with robots? For example, we create something and we need this robot to be controlled. So we don't need to create your own voice recognition system if you want to control it on voice. So we can use actually Google to control voice to text. We can do search for keywords and do some movements on what man thinks. So what do you guys think about taking some artificial intelligence from chatbots into robotics? Basically take anything like Hello, Google Hello, they can make their own chatbot now, Google Assistant, so that you can take some existing projects and products and install them on hardware. So do you think that it will bring more software engineers into this space? But then we'll see the final objective where this chatbot can be used.
Yeah, I want to add two things that I think we're running out of time. So I was wondering if you want to ask questions.
No, I think we'll have like another 20 minutes or so.
Okay. And the second part of what you're saying is it comes down to the module part once again as to what do you want to add to the system. And the thing that I get worried about is that you get companies that they want to sell their product and they want to be able to make it modular, which is good, but then they kind of jack up their pricing. It's a very expensive entity that, okay, well, if you want to work on software, it gives you all the hardware means and ability to add voice recognition and stuff like that. Hopefully there's a way of interfacing or getting into that information to be able to do what you want to do. I'm not sure how that will, because I'm not sure if that whole chatbot thing. But the only thing I worry about is you get these companies that just jack up prices like mobile robots like that. It's so simplistic, yet you can spend $150. It's just
I think that there's room for implementing that level of AI, and honestly, anytime you can bring something new or different into the world of robotics or anything, you're going to get more people's attention and get people who may not have otherwise been interested. So I think there's room for it. But I do have to say that is not my area of expertise, so I don't know to what level that differs from other existing forms of AI that are regularly practiced on existing robots.
Did anyone of you try already?
I tried.
Okay.
Because I'm developing like a humanoid robot as well. So
Like how they go around?
so it has function-wise, this Volvo toolbox, can do some work, but not that perfect. And then if you go for, it's really budget issue. You have to use the open source. Otherwise you are not able to deploy it for anything. And the hardware itself is already very expensive. And even for us, it's made it from scratch. Because I have a machine shop and we have design specialists into the machine, so those costs will be absorbed by the university. But still, even the part is going to be a lot of money. And then software, well, if I have to spend another, $700, probably okay. But if you ask me $1,000, it's not affordable for me. I mean, if this is like robot, in the end it costs me like 10 or 100,000. I mean, what's the point? I mean, that's going to be destroyed.
No, I was actually trying to say that this thing could be also be open source because many chatbots they already have like open API. And you can just
Yes, in fact, we tried that. It's just it's okay for simple demo, but if you want to impress people, then it's become challenging.
I think the challenge with this whole chatbot is that you're thinking about the NLP problem, which is a natural language processor, right? And we are not there yet, still not there yet. Okay. So when you build a robot and you have the communication with the robot, I think having a toolbox which is open source and having the dialogue model, my research of human interaction has taught me, and one of the part was I worked on dialogue part of the robot, and I didn't find robot tools which you can use like off the shelf for dialogue part. I mean, having a chatbot instead of demo is good, but if you want functional, right? So if people work on a functional pieces, it's sometimes the whole system working. Maybe a small piece, small thing, we can get it working, and that could be a good starting point, of course. Yeah. But the other part is a completely different problem altogether. So that's the other NLP problem to worry about, like to make it work functionally. So Google and I think they did a good job with the, and AT&T has this.
Watson.
No, noise. I think IBM has this. I think it's noise in the software from AT&T. They did a good job with the dialogue part. So they have a lot of database on corpus data.
You mean you install the call center?
Not necessarily. They have a whole software which basically do the same kind of voice recognition thing. So when you speak, it basically picks up a lot of AI stuff on the whole research component. And you have a project on that.
But one problem with that is then the CPU of the robot has to be very strong.
That's right. Yeah.
Unless it's cloud-based.
Right.
Yeah. So then this is also very, very, very challenging. And if you want to get a very small and powerful one, it's going to be very expensive. But if you put a laptop there, then it's going to be very bulky.
Yeah. Well, but let's be realistic.
Yeah.
We all have these.
Yeah.
These are extremely powerful. They essentially have an IMU built in.
Yeah.
They have camera built in.
Yeah.
They have high-level processing built in. They have a screen built in. So I never really thought about it to a great extent, but we could have more applications that maybe run on something that everyone carries with them. Plug this into a robot.
So you can tap into that
That's
information.
actually a good idea. Because the problem would be the programming. Right now,
I was going to point to that point. If you look at the Linux website, Ubuntu, you know that Ubuntu is what I remember this. They wanted to create this open source phone, and they have a whole software, but they didn't get enough money to get it off going. But if you go to Ubuntu website, there's Ubuntu software for the Ubuntu operating system. The idea was that you take your phone, you have the whole Linux system working on your phone. You plug it to a monitor. It's a desktop system. So I think that's a good area to tap into. I think if you have the Linux system, you got all the stuff you want to do. So, but I think having a hardware that can run the Linux system and the way the Ubuntu has open source one, I think that'll be a good starting point to maybe address some of the
and some of them are able to handle that, some are not. So within the same class, some no problem, can't speak, or some use like single board computer, they have no problem. And integrate Ubuntu and integrate OpenCV, no problem. But many of them, no. So it's really become very challenging when, if the student with a very strong background, I think can handle. But for high school, for normal, not high school, in fact, for most of college students, they're not. So then probably MATLAB is probably the best thing they can handle. Beyond that, there's no way. And even MATLAB can have difficult program. And then when the solution you mentioned, that's not the choice for most of them. Yeah. For some talented student, no problem.
I think I was going to George about this, the whole creating technology for that system. So we need to come up with a hardware where you can say, hey, here's a mobile hardware you can buy, which is the Linux on it, and you have a bunch of maybe chatbot and stuff working, and that could be, that space could be explored. So it's not for undergraduate student or graduate student, but maybe that could be used for project in general. But I'm thinking of it from the industry wide, because there's money involved, and then you can have people working on the stuff, and then there's something off the, maybe having this Kickstarter project. Kickstarter project.
Once you start talking about finance from industry, open sources, gone for the most part.
No, Kickstarter. See, I'm talking about Kickstarter. Something like a Kickstarter where people, it kind of open source community, kind of, funding this thing and having a movement.
So one last thing, just to make sure that we will get some questions from our audience. So what do you guys think about the FPGA technology for applications? Do you think that it's something that is also required? We spent like a lot of time trying to find out what is actually the application market. You can see that like Arduino, you have Raspberry Pi, Intel is trying to get their like Arduino 101 and latest and something. Did anyone try Intel Korea? So a lot of I would say that these three probably Alulu, Parallab, so there are some. So, but what do you think about the FPGA? Do you think like real-time calculations is a good opportunity to the lack of these solutions for educators? Do you feel this that you need something like FPGA curriculum or hardware product that is doing these FPGAs?
Yeah, I have actually part of my project.
Yeah,
The FPGA. So that'll be having the cognitive map that's used for SLAM.
And it should be like real time.
Yeah, it should be real time. The thing is I try to keep scientific, decimal and floats and stuff off there because it's not a huge FPGA. So the thing is try to do parallel processing, polling of these boundary cells and place cells and all these neuroscience related cells that it's almost like a neural network, but not quite. Although you can do neural networks on FPGAs, but the larger ones. So the thing is that I have to create my own serial interface for this, and it's not bad.